Okay, in this proof we are given that segment JM is parallel to KN. So we know the ones marked with the arrows, JM and KN are parallel, but we do not know that KM and LN are parallel. That's what we're trying to prove. We also know that angle 1 is congruent to angle 2, and that angle 3 is congruent to angle 4. Okay, let's think strategically about this. We are trying to prove that segment KM and segment LN are parallel. So we're going to need to use a converse. Whenever you're trying to prove that two lines are parallel, you're going to use a converse. So we're either using the converse of the same side interior angles theorem, alternate interior angles theorem, alternate exterior angles theorem, or the corresponding angles postulate. One of those four things is, we're going to have to use one of those four things to prove that those two lines are parallel. So let's go check out the picture and see if we notice any of those special types of angles going on. So I'm looking at segment KM and segment LN. And I'm looking for a transversal. So I guess I could think of this line, JL, KL. I could think of this line as a transversal, or I could think of KN as a transversal. There goes my parents' home phone again. Classic. I could either think of either of those lines as the transversal. So if I'm thinking of KN as my transversal, I don't see any alternate interior. I don't see any same side interior. I don't see any alternate exterior. This isn't really going to help me. Ooh, whoops. Sometimes I think my active boards has a mind of its own. So I'm not looking at that transversal. I am instead going to look at this transversal. This line is the transversal. Still don't like that. Let's make it a little skinnier. There we go. Much better. Okay, so I'm looking at KM and LN. And if that yellow line is my transversal, I'm going to kind of extend KM, LN. And the yellow line's my transversal. So I don't have any angles on the top side of the transversal. So I can't use alternate interior or alternate exterior. And I don't have any same side interior angles. But I do notice that angle 2 and angle 4 are corresponding. So if I can prove that angle 2 and angle 4 are corresponding, then I can prove that those two lines are parallel by the converse of the corresponding angles postulate. So one more time. If I can prove that angle 2 and angle 4 are congruent, then because they're corresponding angles, then I can prove that the lines are parallel by the converse of the corresponding angles postulate. So I know that JM and KN are parallel, so I can say 1 and 3, they're corresponding, so I can say that angle 1 is congruent to angle 3 by the corresponding angles postulate. Because I knew the lines were parallel, then I was allowed to use the corresponding angles postulate. Okay, now I have angle 1. That's my first term. Angle 2 is my second term. Angle 3 is my third term. Angle 4 is my fourth term. So I have 4 terms for you use substitution. So because angle 1 and angle 3 are congruent, I can say angle 2 is congruent to angle 4 by the substitution property. So now that I've proven that angle 2 and angle 4 are congruent, now remember angle 2 and angle 4 are corresponding. If I'm considering KM and LN to be my two lines, and then this yellow line JL is my transversal, 2 and 4 are corresponding, and because 2 and 4 are corresponding and congruent, now in step 4 I can say segment KM has to be parallel to segment LN by the converse of the corresponding angles postulate. That says postulate right here, P-O-S-T. And there we go.